Hello everyone. In this video, I'm going to explain AWS auto scaling. So let's move to the agenda and see what are the topics we are going to cover in this video. Auto scaling, why we need auto scaling, what are the features of auto scaling, and architecture of auto scaling. For auto scaling, we need load balancer and target group. At the last, how do they work together? We can see, and um, I'll show you one demo also how to configure those things. What is auto scaling? So auto scaling is a feature in cloud environment that automatically adjusts the number of compute resources such as EC2 instances based on the current demand of workloads. So based on the workloads, the auto scalings can divide the number of instances. So this helps to maintain perform while optimizing cost. So in AWS, auto scaling is a core feature of elastic cloud balancing and works well with other services like EC2 instances, RDS. So why auto scaling? Why we need auto scaling? So it's a critical for modern application, especially in a cloud environment where workloads demands can vary significant. Here, why auto scaling is essential. So the first thing is handle variable workloads. So in this we have two types, that's a dynamic traffic and a peak load management. Dynamic traffic applications like e-commerces or streaming platforms often experience traffic's auto-scaling adjusts resource to meet these demands without minimal intervention. Peak load management. During this traffic peaks, it's add resource to prevent downtime or slow performance. So the next thing is improve performance and user experience. It ensures significant resources are available to maintain optimal application performance during high demand, and its overload of servings reducing response times and improving user satisfaction. So the next thing is it's a cost efficiency. Remove resources during off-peak hours, save money, and you pay only for the resources you need, avoiding over provisioning. The next thing is enhance application availability. It automatically replaces unhealthy instances with healthy one, ensuring continuous availability. Maintain operations by relocating resources in case of any failures. Eliminate manual efforts. So it automations reduce needs for constant monitoring and manual adjustment, saving time and efforts for your operation team. And the last thing is adaptability. Business with rapidly changing demands can rely on auto scaling to update without redesigning infrastructures, work across multiple regions, ensuring application perform well for a global audience. So next thing is features of auto scaling. So AWS auto scaling provides a robust feature for ensuring your applications are highly available, cost efficient, and are responsive to changing demand. So the key features of auto scaling are scaling, centralized scaling management, cost optimization, fault tolerance, and integration with elastic load balancer. So, dynamic scaling, it automatically adjusts the number of resources, for example, EC2 instances in a real time based on demands. It supports different scaling policies like a target tracking scaling, step scaling. Next thing is centralized scaling management. So it manages scaling for multiple AWS services like EC2, DynamoDB, Aurora, and more from a single interface. Scaling plans allow consistent scaling policy across services. So cost optimization ensure that only one pay for the resources you need. You don't have to pay for other one. Automatically scales down during low traffic to minimum cost. Fault tolerance. It's continued checking for the health of the resources and automatically replace well unhealthy instances comes. Enhance applications reliability by maintaining a pool of healthy resources. Integration with elastic load balance balances incoming traffic across scaled resource for better performance and availability. Works seamlessly with auto scaling to distribute load among instances. So the next thing is architecture of auto scaling. So in this target architectural diagram, which we are seeing in the script screen, which are implemented in this session, auto scaling, as the name suggested, which means it auto scale or auto create the EC2 instance into our AWS environment. And how to control those things? Here we need to define a min desire. So there are the numbers denotes the number of EC2 instance, EC2 machines started into our AWS environment. Is the min is the minimum number of the EC2 machines which will be running into our AWS environment. This is the maximum of the number where we will be running maximum number of EC2 instance into our AWS environment based on the load memory and CPU usage. If there is more load and more traffic to the instances, then the minimum number of the instances are run in a AWS environment. You don't need to control the auto scaling group, will take care of those part. So first thing we need to create a VPC, internet gateway, subnets, route tables. For auto scaling, we need load balancer and a targets groups. I will show you how to implement those things. So the next thing is you will a little bit aware of EC2 auto scaling group policies. So let's compare the two approaches. So here we have a traditional setup on the left side corner and a auto scaling group on a right side corner. So let's get into the first picture. In the top of, we can see a load balancer will route the request to our VPC. So it will route the request to our VPC and then it will go into the subnets and where we are provisioning our EC2 instances in the traditional setup. So we need to predefine the number of EC2 instance where compared to auto scaling groups. So it just gives you a flexibility to create more instances and reduce the instance based on the traffic or a CPU usage or memory usage. So in traditional setup, we need to manually configuration. In auto scaling group, we have mentioned the minimum, maximum and the desired state. So it will automatically recreate the EC2 instance when it gets failure. So what is load balancing? So it's a process of distributing incoming traffic across multiple server to ensure no single server is overwhelmed. So the load balancer can distribute the server for the availability server for the reduce the traffic. These enhance application performance, reliability, and availability. In AWS, Elastic Load Balancer provide a scalable, managed, and load balancing solution that works seamlessly with other AWS services. And how these are works. So how load balancers are works. So user request. User send request to a single domain or a IP address. So the next thing is load balancer receives a request. It acts as an intermediate receiving all the incoming traffic and traffic distribution. The load balancer route request to healthy backend servers based on the predefined rules. The next thing is in load balancing, we have four types of load balancing, that's application load balancing, network load balancing, classic load balancer, and a gateway load balancer. So, in application load balancer, provides complex routing based on a HTTP and a HTTPS header or a WebSocket server. Application load balancer examine the requested content such as HTTP header or a SSL session IDs to redirect application traffics. It will redirect the traffic for the available instances. So network load balancer good for applications that primarily uses TCP or a UDP and benefit from low latency and high throughput. NLBs examine IPS addresses and other network information to redirect the traffic. So gateway load balancer can handle high throughputs only. Classic load balancer, a load balancer that is no longer recommended for new applications. It operate at TCP IP level and distribute traffics based on the source IP addresses, port numbers, and a protocol. All of this load balancer offers high availability, auto scaling, and robust security supports. You only pay for what you are uses. Next thing is target group. So it's a logical grouping of resources that a load balancer uses to direct traffic. Define how load balancer routes requested to its target register. How this groups works. So the next thing is how target groups works. So in this we have a association with the load balancer, routing traffic to targets, health checks. Target groups are attached to the listener in a load balancer. The listener routes requested to the associated uh, groups based on the rules. Routing traffic to targets, requests are distributed among the target within a group according to the load balancer type and a health check status. Each target groups has its own LCheck configuration. The load balancer send traffic only for the healthy target. So let's see the real world scenario. Here I have took the example for e-commerce websites during the sales. So here we have three stages. One is normal traffic, second one is increased traffic, and the third one is reduced traffic. So let's see what happens in a normal traffic. During regular days, the website service receives about 1,000 requests per minute. The load balancer routes traffic to EC2 to EC2 instances in the auto scaling groups. This is what happens in a normal traffic. So what happens when the traffic gets increased? On the traffic spikes to 50,000 requests per minute, autoscaling detects the increased CPU usage on current instances. It adds 8 more instances to the autoscaling groups. So the load balancer automatically start distributing traffic to all the 10 instances. When increase traffic get increases, the autoscaling groups will distribute all the available EC2 instances. So what happens when the traffic gets reduced? So after the sales, traffic drops back to 1,000 requests per minute. Autoscaling remove extra instances, leaving only the original two instances. The load balancer continues distributing traffic to the remaining instances. So here starting we have only a original two instances. If the traffic get increases, the auto scaling creates extra 8 more instances, and while traffic get reduced, the all the traffics will remove, and the only the original instances are linked. So this is how the examples are work in a real world. So let's go and implement the auto scaling, load balancing and target groups. I'll show you one by one how to implement those things. Let's go to the AWS account and open a VPC. So before creating all this, we need to create first VPC and all. To VPC, create VPC. So here I'm go with the resource to create VPC and more. So here I'm giving the name test VPC. Publicity. I don't need a public subnets right now, so I'm unchecking the option. Yes, the public IP should be 10.0.0 bar 16. So click on create VPC. So create a VPC and subnets along it, only attach it to the internet gateway. So and also it create a route table. So let's go and check. So the VPC has been created. So refresh the public subnets has been created. Route table is also created, and the internet gateway is also created. So let's go into this. So see the internet gateway has been attached, and go to subnet association. See the subnet has been associated with this. So the next resources which we are creating is a target group subnet. We will creating EC2 instance, and those will be a part of the target groups. So when we'll be creating load balancer, we point to the target group, and this target point the EC2 instances, and this is how it's going to work. So go to scroll down, go to target groups. So click on create target groups. So basic configuration, it will instance only. Then give the name target EC2, get EC2. Select the VPC you have been created and scroll down, click on next. So there is no instances which has been created at. Those instances will be created by auto scaling policy. Just create a blank target group as of now. Create on target groups. So go to load balancer. So click on create load balancer. Here I'm creating an application load balancer. Click on create. Give the name for this. I'm giving the application load balancer EC2 with auto scaling group. Scroll down. So it on VPC you have created. So it will show the availability zones. Click on all the availability zones, scroll down. So here create a security group, give the name for the security group, that is auto scaling application load balancer security group for HTTP request. Give the description, allow HTTP request. So select the VPC we have created, and in inbound rule, add rule. So here we need to give the access for HTTP. So it source. So create on security groups, security group. So which will created. So go to load balancer, refresh this. So yes, we have selected this. So this will, so in the listener you need to select your target which you have been created. So the rest of the thing, so here check for the summary, security groups, network mapping, and routing. So click on create load balancer. So the balancer will created. So the next, click on create auto scaling group. Give the name auto scaling group PC2 test. So here we need to create a, click on create a launch template. So launch template EC2 instance. So template description. So I'm using a machine Ubuntu because I'm familiar with the Ubuntu, so I'm selecting this. So instance type should be a free eligible T3 micro. And if you have an existing keeper, select existing keeper or click on create new keeper and create a new keeper there. So scroll down. So the next thing is security. Click on create security. So give the name launch template security group for EC2 instance. So allow SSH and HTTP request. So select the VPC we have created. So on the this we need to add a rules, add. So SSH, source type anywhere, add security group. So HTTP and source should be anywhere. So us then the rest of the things will be same. So yes, create a launch template. So select this one. Next. So here select the VPC we have created. Select all the availability zones. Click on next. Here load balancing, attach an existing load balancer. So select the target group which we have created. So enable this one. So I will set to this for 20 seconds. So next, one more required field. So health check once again. So uncheck this. So turn on elastic load balancer for the L check. This should be turned on. So and this is 20 seconds. Click on next. So here I'm giving the desired capacities to 2. The minimum capacity desired is 1 and maximum is 3, and the rest of the thing will be same, and the additional capacity. So click on next, click on next, click on next, and create auto scaling groups. So as the auto scaling group has been created, easy to. So see, the two instances has been created by auto scaling groups. So let's get enter to this. So see, instance management to healthy. So let's go. I'll just delete one. I'll terminate one instance. So let's see if in case failure the auto scaling, what the auto scaling will do, it will automatically create the same server. So let's see whether it will create it or not. So see, so let's wait, it will take some times, so let's wait. So see, it's showing an unhealthy, means the server got failure. So refresh is the another instance has been created. So see it showing an the pending state. So another is in service means it has running. So another is terminating it. For that it will showing unhealthy. So refresh. So the pending status will changes to the in service. So this is how all about how the load balancing target groups and auto scalings are work. That's all about the auto scaling. Thank you.